Privacy Visa team. This is me, this is Chris. So we're gonna just update our progress. Just to recap for everyone again what we do. So we are preventing cardholders to trust the merchants to keep their card information and CVV numbers. So as you can see in normal flows of what's happening, there's a required trust between cardholder and merchants. And it's not always secure. Like we can't control what the merchant's database system or their security systems are going to be. So with Privacy Visa, users doesn't really need to input their CVV and card numbers when they do a purchase in the store, and the shop therefore can accept or store those information. Yeah. So we have divided the flow of how Privacy Visa works in 4 steps. Sorry for the technical problem. So the first step is the setup where users will generate the credit card through Privacy Visa with the bank. Therefore, shop is not involved in this progress. User requests the card setup and then generate proof and then store the proof with the bank. And then when users want to initiate the transaction or do the shopping to the shop then receive the request from users, then send the information to the bank and Privacy Visa to verify. And then when Privacy Visas receive the information received from the bank that the user sent, then they could generate the proof and verify with the existing proof in the setup stage in the beginning to see if this is valid or not. And then they can send back to the users, to the shop and the users to respond if the verification is complete or failed. And this is the zero knowledge part of the project. We just scope them for you to easily understand. On the setup part, we hash the card number to public input 1, that we receive the card number from the bank, and the users generate salts and CVC from themselves, then hash them twice, first with public input 1, and then resulting in public input 2, and then use public input 2 plus generated CVV to hash them again, and then send public input 2 and 3 to the bank. Therefore, bank will only store public input 2 and 3, but also not the salt and CVC. During the verification process, when users want to buy item at the shop, first they wait to pay, and the shop, when they got the transaction information, which includes transaction number and the amount that users require to pay, they send to the bank and the users. When the bank receives, the bank will generate, use those information to generate the X that I showed in the diagram with PIA, transaction, and nonce. Then sending the nonce back to users. While users receive nonce, he generates PIA, TX, and nonce as a PIB. Then users send PIA and PIB to the bank, and then bank could verify if PIB equals to the X value that they previously calculated.
Okay. Okay, so next to the demo. I should run the 4 things. The first is the bank, and back end shop and the shop front end, and the last one is the privacy visa. No. Okay, so the first the app that I have to do to is the setup stage. So I assume that the privacy visa get the data from the bank, that the two things for generate the proof. So after the user generate the proof, user have to send the proof and the public signal with the card number to the bank. For bank can the mapping with the PI3 and the card number to bank can know. Yeah. So after that, I user going to the bank, no, the shop. No, no, no. Wrong port. Shop, okay. Okay, so this is the checkout phase that the user want to buy something, and use in the shop user just fill in the PI3, and that means shop doesn't care about doesn't get the card number or the card details, CVC, something like that, and the user just proceeds the payment, and this the redirect to the privacy visa, and the shop send the TX to the privacy visa. Also at the same time, the shop requests to the bank to generate the transaction for the user, sending the proof and making the payment to sending the balance to the shop. Yeah, and also the privacy visa also get the notes from the bank, that bank can checking with the user have the note start with the zero, and the other payment with the something like it is account. Yeah, for the notes, and user just fill in the card detail. So after user send the proof to the bank, the privacy visa should redirect to the same shop, and the shop will checking the transaction payment in the bank. We use it in the background, and this is everything is done. So you can see the bank. Okay, I will pause this. You can see this. This is the balance of the card. You can see the balance of the card number of the user is sending to the card number of the shop now. Yeah. So this is the way that I take to the CK with the shop. Doesn't care about the card number. We just send the PI3, and user generate the new proof with the card detail to and the transaction to the bank, can verify the new proof with the transaction of the user. Thank you.
Oh, yeah.
Can you get back to the slide? Yeah, that's slide.
Previous one?
Uh, the last one.
Last one.
Yes. So here, I think in the protocol you introduce like the stop, right? And the stop is like installed by the user, right?
Yeah.
So in order this salt could be like 256 bits,
Oh, yeah, yeah, yeah.
right?
I see, I see.
And yeah, and like having the user to have to remember that you know long string is kind of like break the purpose of the using the CDC. Right? So
Yeah.
how can you solve this problem?
Actually, I think the salt should be more, yeah. But in this the demo, I just want to make sure that everyone can know that I send the salt in the Circom and Circom taking the salt to create the proof. That's it. But in the next step, I think we can improve the salt.
And also that I think that when you introduce the salt, can you compare it with having the user create their own symmetric key and have the byte set a public key inside the byte?
You mean the setup the PI3
Yeah.
with
So
the new?
here you require that the byte will have to change their process, right?
Okay. So I think this is your question about the proof.
And I want to know that if it's simpler that you can just create a symmetric link and have the byte set a public key
Mm.
instead of like having to use ZK here.
So yeah, this is the verify transaction that the user send the PIA that's come from the same data like the setup phase. So the bank will check the PIA with the transaction and the nulls because the shop doesn't know about the nulls. Shop just create the transaction order and send to the bank. And also bank already know the TX, and the bank also know the PIA because the first step is the setup phase.
Yeah.
Yeah. So the this function can checking with the verify that the PIA and the all transaction is and the next I checking also the proof and check the two. This should be the same.
Yeah. Okay.
Yeah.
Thank you.
Thank you.
Is it correct that the reason we need to use the gate is to not to trust user to sign like the correct transaction? Because like if you use
Asymmetric.
encryption,
It just create the proof, not asymmetric encryption for now.
yeah, otherwise you could do
Yeah, yeah, yeah.
reliable encryption or reliable signing.
Yeah.
Okay. Yeah, and I guess you concluded that doing hashing.
Yeah. In the next step, I think we can make like the Stripe. It's a payment gateway that they're working with the bank to the when they working with the bank, they will create the card network which the user no the shop integrate the Stripe SDK and sending to the Stripe server, and Stripe server will checking the card detail of the user. After that, the Stripe checking the card number with the bank, and I think this also can be like, yeah, but we just taking the CK for nothing, fill the card detail to the shop.
Okay.
Yeah.
Excuse me, one more question. Here you in the last step,
Yeah.
the user send plain text, PIA and PIB to bank.
To bank,
Yeah.
you want to see this?
PIA, right?
The PIA is come from this
Yeah, yeah.
card detail.
Yeah. But they send the PIA in the plain text to the bank, right?
In actually yes, but in the next step, I think we can make more the secure like the TLS or HTTPS or yeah, that's also
no,
be.
TOS is like communication between
Yeah, it's
user.
just communication.
Yeah. So here, assuming that the user already executed a transaction before, and
Mm.
they set the PIA and the PID to the bank,
Mm.
then the bank can use the PIA to like create any valid transaction on behalf of the user without the consent of the user, because the PID is like a combination of just PIA and transaction,
Ah, yeah.
and that's and that's not secure uh,
For
for the
you
user.
mean I am sent to this, right?
Yeah, because the PIA is not changed for like every transaction.
Yeah.
So when you use it, the
Okay,
bank
okay,
can
I see.
create like any valid
Yeah,
transactions.
I see. That's a good concern about the PIA. Okay, okay. I will think this the next time. Interesting.
Yeah, yeah. Okay.
Okay.
Do you have every? So in case if you have a suggestion or recommendation, you can come to us afterward as well.
Okay. Thank you.
Thank you.